everyone. For this video, I'll be discussing to you one of the uninformed search algorithm under artificial intelligence, which is the breadth first search, or also known as BFS. So BFS uses the data structure queue as its behavior for its frontier. Frontier is your container or represents the memory of the nodes that you're going to be visiting next. No? So starting with the node S, so we put S in our frontier here. Again, Q uses the concept of first in, first out, or FIFO. So if you call S, you need to check all the adjacent nodes to it and insert it in our frontier. So to make the order, so we will be using the same order. For this video, I'll be using left to right. However, you can select which order you want. However, make sure that if you select the order, you should be consistent. So for me, I'll be using left to right. So throughout the video, I'll be using the order of left to right. If you use like right to left or other way, make sure to be consistent with it. So again, we'll start with S, and then let's check the adjacent node to S, which is X, Y, and Z. So these nodes will be inserted to our frontier once we called S. So S will be removed from the frontier. So let's change color. So S will be called, and all adjacent node will be inserted to our frontier. So I'll be using left to right approach, which I'll insert first X, followed by Y, then followed by Z. And we will be doing the same behavior again and again. So we will call X. Let's call X here as our node. And let's check X. So X contains A and B neighbors or adjacent nodes. So we will be inserting A and B to our frontier. So first, we need to rewrite the remaining nodes in our frontier, which is Y and Z. Then let's insert A and B here, A and B. Then let's call again our next node, which is Y. So let's call the Y here. And then check our node Y. So Y contains adjacent node, which is L and M. So we need to insert L and M in our frontier. So again, we are using the order left to right. First, let's rewrite the current nodes. No? So Y was already extracted or removed. So remaining Z, A, and B. Then let's insert the adjacent node to Y, which is L and M. And then we do the same process again. The next one in line is Z. So let's check Z. So Z contains T, U, and V. So basically, if you dequeue or remove Z, we need to insert T, U, and V. So let's first rewrite the remaining nodes in our frontier, which is A, B, L, and M. Then insert T, U, V at the end. So same process goes again. We extract A here, then check A for the adjacent nodes, which is P and Q, and then rewrite everything in our queue, which is B, L, M, T, U, V. Then insert P and Qs, last part. Then extract B, which is our next node. So B will be extracted. Check B. So B has one adjacent node to it, which is N. So we will be inserting N, but first we need to rewrite first our remaining nodes in the frontier. L, M, T, U, V, P, Q, and then we insert N. So reminder again, those nodes in highlighted or in color yellow is our goal nodes now, our goal state. So once we reach this one, we stop our um, traversal. So going back, the next inline is L. So let's check L. L contains E and F as adjacent nodes. So let's remove L from the list. Rewrite all the remaining nodes from the frontier T, U, V, P, Q, N, and then insert the newly adjacent nodes is E and F. Then next in line is M. So we call M as our node. So from this one, you can see that M doesn't have any adjacent nodes to it. So we just insert nothing. So basically, we will be just copying all the remaining nodes here and nothing will be inserted. And then next is the node T, which is this one, node T. So let's call node T. So as you can see in our graph, T is highlighted, meaning this is our goal state. So we stop our traversal here since we already reached our goal. So let's use color green. This is our goal. So the nodes in this column represents what we call the node expansion. So our node expansion is, so our order, let's rewrite that one. So our order of node expansion is, so we just write this from starting the first up to the last now. So we have here, we started with S. So we have S followed by X, followed by Y, followed by Z, followed by A, followed by B, then followed by L. So I'll just write it below, followed by M, and then followed by T. So that's our order of node expansion. So basically, this is our answer. Yeah. So to make it clear, let's have the next slide, which is this one. So this slide shows the what we did earlier. And again, our node expansion is S, X, Y, Z, A, B, L, M, T. So you can write it with arrow or without. So again, we're okay. So again, our um, order, of node expansion. Wait, I need an order of node. So our order of node expansion is, so you can write with arrow or without. So S, X, Y, Z, A, B, L, M, T. Yeah, so that's our answer. So that's it for this one. And we'll move now to our next topic.